let's talk about regression. There are 7 different types of regression listed up here and only 6 pictures, so one of them is going to get left out, but let's figure out which one it is. Here we go. The first one is, I'd like to think, is pretty obvious. You can draw a straight line through that, therefore it is linear. It could go up, it could go down, could have a negative slope also. This next one looks like a parabola to me. It can go this way, it can go this way. Warning though, sometimes when they only draw half of it, it can look exponential. Like if they were just to do this part of it and it goes like that, people would confuse it as exponential. So just be careful with that. Quadratic. And the next one is exponential. The big difference between exponential and quadratic, first of all, is this is only half of that one, but it also sort of lays off on one side. It kind of lays low. It's an asymptote basically. If we kept this going this way, it would never touch the x-axis. That's what an asymptote is. So this one is exponential, in case you care, and you should. This is exponential growth. I could draw another one that could be exponential decay, and it would sort of come down here and it would sort of hover above the axis depending on how it was. Either one of those. This next one is logarithmic. It's the inverse of exponential. Logarithmic graphs start kind of almost vertical and then quickly level off like that. This one is one that we've not dealt with very much, but it's called a cubic graph, and it goes like this, or it could be upside down. It could go like that, or it could be a little more flattened and not as pronounced. It can do like this, which is what this one does, or it can go like that. Either one of those. Looks like a person shrugging their shoulders. This one can be mistaken as a cubic when it is actually not. This one is periodic, meaning if I was to continue this pattern, I could just keep this thing going, and oh my goodness, I just drew a sine graph. So this one is sinusoidal. There it is. Emphasis on the sine, not sin. Okay, let's type some stuff in the calculator and figure out what the equation is. Geologist is analyzing the erosion of a coastline over the past 5 years. Most of the time when you're given a table, you're going to have to use what I'm about to do. This is the Scatterplot stuff. You've seen it a zillion times. Zillion is not a number, by the way. The table below shows the relationship. Most of the time the top one is x, the bottom one is y. Most of the time, I've never seen an exception to that on an exam. I will warn you though, time is always x. Time, well, until you get into hardcore physics, time is x. So, you press, well, let me get you there. Press stat. Press enter on edit. If you have anything in your lists, clear it out. If you accidentally delete a list, reset your memory. There's another way to do it, but it's probably easiest if you just reset your memory. Anyway, 1, 2, 3, 4, 5, 10, oops, 1.01, 2.81, 6.51. How about I do that one right? 6.51. 1014 and 1632. There we go. Okay, we need to see what this graph looks like. So we're going to turn the scatter plot on. So we press second and stat plot. Make sure plot 1 is on. Make sure it's set to be a scatter plot, which it normally is anyway. And we want to see this graph. So we're going to press zoom and go to number 9, which is zoom stat. You can just press the number 9 also. There we go. Now, first glance, probably linear. However, I'm not going to go with linear on this. I'm going to treat it like an exponential graph, because if you look, it looks like this one, only it's not quite as pronounced in its curvature. So it's a little flatter, but I think it's exponential. I'm pretty convinced it's exponential. Level down here somewhat, then comes up rather sharply. Which type of regression best fits the data? I just told you. Exponential. Write the equation. Believe a will. Thank you very much. Stat. We want to calculate an exponential regression. Everything you need is on this list. Linear, quadratic, cubic, quartic. A different type of linear. Natural log. Don't confuse that with linear. Exponential. Let's keep going. Power regression. Logistic. That was an interesting one. Sinusoidal. And then we get some other crazy things down there. Where were we? Exponential. They give you an A and a B. I'm going to round to 2 decimal places. So y equals 0.64 times 1.98 to the x power. Let me tell you what all this means real quickly. If at time 0, if x was 0, after 0 years, there would be this many feet of erosion. And 1.98 means 198%. So it is increasing in erosion by 198% each year, or by 98% each year. Okay, using the equation, how much erosion can be expected after 8 years? Well, 8 is time, so here's the easy part. Y equals 0.64 times 1.98 to the 8 power. We'll type it in, 0.64 times 1.98 to the 8 power. There it is. The answer is 151.18 feet. Real quick, I want to show you something else. Calc. Exponential regression. What I'm about to do is show you, just to remind you, refresh your memory, on how to store this in the calculator as y1. So press vars, go to yvars and hit enter on function and enter on y1. And when you do that, that equation in all its decimal glory is saved under y1. So now if you were to graph it, you would see the dots and you would see the equation at the same time. And so if they asked you several of them, whoop, missed a point. Whoop, missed another point. If they were to ask you several of them and they said, find what happens at 8 years, 9 years, 10 years, you can go to the table and you can just scroll around and find what you needed to.